So today we will be covering multiplying matrices together with each other. The first kind of multiplication we'll be dealing with is a matrix multiplying with a number. So how you would do this is that the number will have to multiply with each element inside the matrix. So for example, A11 would be the number, which is 2, times 6, which is A11. So that would equals 12. And then you would put where that spot goes in row 1, column 1. And same with A12, which is 2 times 12 equals 24. And that's where it goes. And A13 would be 16, 20, 8, and 18. So that part is pretty simple. All you gotta do is that you have to multiply you have to multiply the number with each element of the matrix and in the matrix, and make sure the number and the element multiplied together, they stay in the same spot. So the first thing about multiplying matrices is that the order is important. It's not like multiplying two numbers, just two regular numbers together. You cannot change up the order when you're multiplying matrices. The order matters. But the dimensions, they can tell us whether the two matrices can be multiplied together. So the two inside numbers, they tell us whether they can be multiplied together, and the two outside numbers will tell us what kind of product. So if these two numbers, if they match, it means that they are able to multiply together. But since these two numbers don't match, therefore we cannot multiply them together, and the answer is no solution. But since these two numbers, since they match, it means it is multipliable. And these two numbers, they're both 2's, so therefore the answer will be a 2 by 2. Same thing with this problem right here. So these two numbers match, which means that it's able to be multiplied, and these two numbers mean that the answer will be a 3 by 2 matrix. So this is a simple example of multiplying two matrices together. So the first thing we have to figure out is that whether these two things are able to be multiplied together, and what kind of matrix it would be. So they're both 2 by 2's. The inside numbers tells us that they're able to be multiplied together, and the outside numbers tells us that it's going to be a 2 by 2 matrix. So set up your answer as a 2 by 2 matrix. Now the first spot we want to fill is this spot right here. And how we do that is that we multiply A11 and B11, and then add A12 with B21. So first multiply A11 with B11, which equals 48. And then A12 times B21 is negative 21. And you add them together, which makes 27, and we're going to fill it right here. And the next thing we have to fill is this spot right here. And how we're going to do that, we're going to multiply A21 with B11 and A22 with B21. So A21 is negative 4 times 6 is negative 24. So negative 24, and then A22 times B21 is 35, positive 35, and you add them together, and that will make 11, and then you put your answer right there. Next spot we want to fill is this spot right here, and you would do A11 times B12 and A12 times B22. So 80, so 8 times 10 is 80, and then you would add 3, No, we had to multiply 3 times 1 first, and then you add them. So 80 plus 3 is 83. And then you would do A21 times B12, which equals negative 40, and A22 times B22, which equals negative 5, and then you would add them together, which will make negative 45. And that right there is your answer. This problem is it's not different from the other one. It just looks different, but it's not different at all. So first we gotta figure out whether these things can be multiplied together as usual. So right here we have a 1 by 3 matrix and a 3 by 1 matrix. The inside number tells us it's multiplicable, and the outside number tells us it's going to be 1 by 1 matrix. So this is only going to be one answer. And what we got to do is that we have to multiply these two numbers together, which will make 0. Then these two numbers together, which will make 6. And then these two numbers together, which will make 3. And you will add them all together, which will make 9. So the only answer to this is just simply 9, but you still have to put the matrix box around it because it's still a matrix, even though it's only one number.